All right, thank you very much. I've just received a message from Aaron that we are live now with our students.
Okay.
So it's my pleasure to say good morning, everyone. Welcome to SAS 5P04 and our next seminar in our Transdisciplinary seminar series. It's my extreme pleasure this morning to welcome Dr. Pedro Ponce Cruz to our seminar. Thank you so much for joining us. I'd like to just briefly introduce Dr. Ponce to you because his track record is extremely impressive and just is demonstrative of how much excellent research he is leading in this area. So Dr. Ponce holds a master's and a doctorate of science in electrical engineering, specializing in automatic control. He's a research professor at the Tecnológico de Monterrey, the Mexico City campus. He's a member of the National System of Researchers in Mexico and the Mexican Academy of Sciences. He has received recognition for teaching excellence from the National Polytechnic Institute and the Medal for Academic Merit as the best postgraduate professor of the Graduate School of Engineering and Architecture of the Tecnológico de Monterrey. Dr. Ponce was awarded first place in the International Graphical Systems Design Award and in the category of Biotechnology and Life Sciences by the National Instruments Company in the United States. He also has received the Quo-Discovery Mind Award in Mexico City and is a member of the Distinguished Professor Circle at the Tecnológico de Monterrey. Dr. Ponce has published an incredible more than 200 academic articles and conference papers, 15 published books, 20 book chapters in mechatronics, electronical engineering, and artificial intelligence. In addition to that incredible track record, he has 1 patent in the United States and 4 Mexican patents. So it is such a pleasure to welcome you to our seminar series this morning. Dr. Ponce will be sharing some of this humongous body of work with us this morning. And in particular, he's going to be talking about a strategy for increasing energy savings through smart thermostats. So I really hope that you enjoy the talk this morning. Feel free and please engage with us. So Aaron will open the chat box for you towards the end of the talk. And please, we've allowed some time for questions at the end. So please enter your questions and we'll have an opportunity to have a discussion with Dr. Ponce after his presentation. So thank you so much, a warm welcome, and the floor is over to you, Dr. Ponce.
Thank you very much for inviting me. I am very happy to share with you this novel strategy that we are working on. So the name of the talk is a strategy to increase energy savings from a smart thermostat. And in this talk, I will try to give a very strong push in order to try to include the end users, the behavior of those end users, and also how can we improve the quality of the life in the end users inside of a smart house, of a smart building. So I hope you enjoy this talk. This work is a collaboration work with UC Berkeley, UC Davis, and we have a lot of students work on this project. So the idea is to share some knowledge that we are creating regarding the behavior in Mexico using thermostats and the behavior in US, and try to share ideas in order to improve the quality of the proposal. So the outline is, I will give a very introduction about smart cities, smart grids, smart homes. Later, I will talk about thermostat, connected thermostat, export products. That is like a kind of new concept that we are trying to develop, and how we are trying to create these new products called export products. And at the end, I will talk about a framework that we are working on that includes specific elements in order to saving energy and try to increasing the life of end users. So I will try to explain first how the citizen is involved in this kind of topologies. At the end of the day, the citizen have different needs in a city. For instance, safety, public transport, smart marketing, retail, healthy issues, recreations and things like that. So all this information is a lot of information. And when we talk about smart cities, all those kind of needs have to be improved. And the citizen has to receive specific information about those um, needs. I mean, maybe the government of the city has a very clear way to improve the public transport, but all this information has to be transmitted to the end user, and the end user receive on the cell phone, for instance, and he is able to decide which is the best road to take or something like that. The same things happen with energy. We usually don't receive a lot of information regarding energy. Maybe we are not aware how much energy we are using and the importance of this energy. So we are thinking that the cell phone or a mobile device is a good element for sending only the main information to the citizens in order to try to include them in the cycle, in the circle of the smart city. So the smart city includes a smart community, and the core of this is the smart homes and the smart buildings. But for instance, we have specific devices for energy, security, and health. But we are thinking that maybe some devices can share this task. For instance, if I have a video camera, I can use this video camera for security and healthy issues, but also I can use this video camera for energy, excuse me, for energy issues also. So at the end of the day, we can create devices that can be integrated for using inside of a smart home or a smart building and try to deal with security, health of energy. And when we talk about smart cities, we think in a connected community that all the information is trying to push to improve the quality of life of each individual, but also of the community. So one of the key points is try to create very specific devices that can be smart, sensitive, sustainable, and also social. So I will talk later about those kind of devices that we are talking, and we are try to creating this kind of improvement in these devices. And in terms of energy, the smart city is the most important concept right now. But right now it's a concept. It's very difficult to create a smart city because it's not only the technological aspects for building the smart city, it requires more than that. So the idea is to try to include those devices in the smart city based on a smart grid. So the smart grid is part of the concept of the smart city. So at the end of the day, we can create microgrids, and those microgrids includes smart houses and smart buildings. And inside of those smart houses and buildings, we can include very smart energy devices, and we are working on thermostats. And this is a figure about the smart house. In this smart house, we can include, for instance, solar energy, and we can install those solar panels, and we are very friendly in terms of the environment, but we have also to save energy for complete the performance talking about energy. Because if you only install the solar panels and you don't change your energy behavior, we don't believe that you solve the problem. We have to create those devices that can help you to give some advices or sending you messages in order to save energy. So the idea, as I told you, is to have smart buildings, smart cities, and those are connected in a grid, in a complex grid called a smart grid. As I told you, a smart grid is a concept, but this concept involves a lot of different techniques. For instance, you can integrate in a better way renewable energy as wind and solar, but in this kind of topologies, it's very important to include devices inside of smart houses and smart buildings. The classification for creating a smart grid can be um, starting from the very small blocks that called picogrids, nanogrids, microgrids, and at the end you can create the smart grid. So the idea for us is try to start from the basic, and the basic for us are the small devices, and then try to scale to nanogrids, microgrids, in order to reach the main goal, that is to build the smart grid. So in this way, we can create small units inside of the smart home, and we can be able to manage the energy, the amount of energy that you are spending. As I told you, you can install a solar panel, and you can have those elements, energy elements that are connected, but they can save energy, but at the same time they can communicate each other and know more about the end user. So if you know more about the end user behavior, you can promote saving energy. And the reason that we are using thermostat is because the global warming is affecting the worldwide. So it's very important to be aware of that kind of things, because right now, if you see this graph, the smart thermostat market is increasing very fast. So the idea is not only to save energy, is part of the deal. But at the end of the day, we have to change the behavior of end users. So if the end users are aware of saving energy, they will be more effective in try to avoid problems like global warming. In terms of connected thermostat or smart thermostat, in general, they are very important because they spend a lot of energy. And right now, they can reduce a little bit the amount of energy that they are using, but they have some problems. They are not well accepted, and they are not adopted, and usually a lot of people have a lot of problems when they are using it because they are difficult to program or something like that. At the end of the day, we think that we can create a better device, smarter than these ones, and also try to connect in this new task that is saving energy to the end user of these elements. So we include a new strategy inside of the thermostat called gamification, and I will talk a little bit more about that in the next slides. But for us, gamification is very important because we can engage the end users, trying to increment the amount of energy that they are saving, but at the same time they receive some rewards that can promote the improvement of the quality of life. And the idea of S4 product is they can sensing, smart and sustainable and social. And social is that they can communicate with different devices at home. For instance, you can see a fridge or a washer machine or things like that. And those devices are connected, and they are informed to the central unit how they are behaving. I mean, how the end user are using these devices. So at the end, the central unit can plan a strategy for promoting saving energy, not only in the thermostat, but on in the whole smart house or building. And the idea also is that the way that is communicating these devices information to the end user changes. And the main goal is try to change and promote saving energy to the end user. So the main idea here is try to create devices that change the way that they are interact with the end user, and also they share information with other devices in order to create a structure or a model about the energy behavior of the end user, and then try to change the idea to the end user in order to change the behavior of the end user for saving energy. So these kind of devices, they have a very clear communication between them, but one of the problems is try to improve the interface or the communication with the end users. The first approach that we started working was try to understand what happened with the actual interface thermostats. and how is the interface in this thermostat, and how can we improve the way that they are communicating. So we in this exercise we try to create an stereotype of persona, but basically the information that we use it for creating an stereotype and try to understand what is happening with the thermostat right now. We create this information using the social networks. I mean, we can use Facebook or Twitter or things like that have a lot of information, public information, in order to create an stereotype. And if we can create an stereotype, we can understand more about the end users and the problems that they are trying to tackle for improving the interface in the end users and how they are using the thermostat. So in this approach, all this information was explored and try to filter the information in order to create a thermostat. And this is a persona, it's a virtual persona with information that we found in social networks. And using this information, we compare with a real thermostat, and we propose this kind of thermostat that are smaller, with less buttons and different display and things like that. But the thing that it was amazing here that this information provide those enough information for designing a thermostat. And we evaluated this thermostat in California, and it was a specific population, but at the end of the day, they 80% of the people adopted this idea of this thermostat, and they prefer this one than the old one. So what I am trying to say is that we have a lot of information that we can use about to try to define a model for the end users and try to know more about the needs that they have, and also try to improve the products that they are using. Instead of creating a lot of surveys, you can use this kind of information and you can go directly to create a model. After that, we say, okay, they have a lot of problems like usability and functionality when they are using this kind of devices. Why don't use this information in order to train an artificial intelligence system that maybe you can use your phone and take a picture, and using this information, you can detect usability problems in different thermostats that are already in the market. So maybe a end user can take a picture and can detect some problems and how can be avoided using a different one. So we create this system that is mainly designed to detect the usability and functionality problems only using images. So you can take a picture of a thermostat and it'll automatically detect the main usability and functionality problems that you can probably uh, you can experiment in these kind of devices. So those are some experiments that we do, trying to change the size of the numbers on the, or maybe the position of the power button or something like that. So at the end of the day, those are very critical elements that have to be in a correct position inside of the thermostat, and also the information, it has to be very clear in order to be a good product in the market and also a good product for the end user. If you observe here, this thermostat has problems with the buttons. They are very small and they are not well presented. And for the end user also, it's difficult to manipulate and controlling this kind of thermostats. And see, this could be a very good option if you are trying to understand more about the thermostat and the problems that they have, using usability and functionality as main functionality and as main features. So you can detect all these kind of things using your cell phone. And then we move in a very specific way. And the goal was try to understand more about the consumer. So now the interface, we know the problems that the interface has in terms of usability and functionality, but also we want to know more about the consumer or end user. In this case, if you observe in this figure, you can see that we have a classification system. It means that we will send some stimuli to the end user, and we will see what is the response, or what kind of response the consumer um, send to the system in order to try to improve the interface. I mean, the interface can be tailored, and if you tailor the interface, it will be a better interface than a conventional one. But the problem here is try to understand online the consumer needs and how he is manipulating this interface. So in this case, we use a classification system, and we are sending signals to the consumer, and we receive the response, and we are adapting this system online. And the goal is try to promote saving energy. So we send signals about saving energy, and we say, for instance, you have to close the windows before you are starting using the air conditioner or things like that. And we realize what kind of response the consumer start to sending. And in this way, we change the way that we are communicating with the consumer, because we change the messages and things like that. But this interface was good, but was not good enough, because we have to engage the consumer in this kind of structures. So as I told you, one of the key points here in this kind of interface was to include the gamification strategy, because in this kind of interface, there are very few end users that were interested on using this kind of interface, in which you are trying to sending some information, and you have to receive information from the consumer or the response of the consumer. And the way that we found that is better to try to run this kind of interfaces was including the gamification part. So in this new interface, also we have the same strategy that here, but we include the gamification. This is the reason that you can see in this figure that is include the rewards, and you can see that those rewards are included, but you have to be very careful, because not all the rewards are the same for the same people. I mean, there are persons that prefer a specific rewards. Some people prefer money, another they prefer a badge that can be shown in a social network or things like that. So the way that you are tailoring the rewards that you can include in the interface, that is the interface for a smart thermostat, you have to be very careful. So this is the reason that you have to start with a very basic questionnaire, 5 or 6 questions, in order to try to classify the customer or the end user. And using this basic information, start sending signals and receive the response of the customer, and see if you can engage the end user. And if you do in the correct way, those rewards are very interesting, because they promote to saving energy in a faster way that using this kind of interfaces. So this is one of the mock-ups of the interfaces. You can see that we have rewards, and we show the information regarding the temperature and things like that, but they are more dynamic. I mean, those elements are not the same for all the people. They are changing according with your needs and your behavior. So those elements are changing, and all the rewards are changing. But one of the things that you have to keep in mind is, I am talking about first about the smart cities and smart communities, and I am talking here about the end consumer. So one of the key points here is try to integrate the community in a gamification strategy, in having individual needs and community needs about the energy. So you can see in this figure that you have a smart home, but this smart home is connected with different homes. So you have a smart community, and the idea here is try to promote in a community to saving energy. using as a main interface the cell phone in this case, but it could be a mobile device and as an iPad or something like that. But the goal is not only to save energy in one house. The idea is to try to promote it to saving energy in a community. So all the systems are interconnected and they are saying, okay, let's do it a gamification for all the community and try to promote to all of them to saving energy, giving different rewards. So this is one of the key ideas that we are keeping in mind. And the interface is changing, as I told you, but also the rewards are changing. So at the end, all the community is involved in saving energy, but they are inside of a big gamification strategy. And the way that we are knowing more about the community and persons is about is using artificial intelligence algorithms. So they are running online and they are trying to describe the behavior of end users and the behavior of the whole community. So it's not so easy to understand all the behavior of the end users or the community. But the first approach is try to create a general model, and using this general model, we can go deeper. Every time that the end user is using the interface, we know more about how is using the energy, how can we improve the quality of life of these persons in terms of energy. And as I told you, this interface is changing all the time according to a specific behavior of each individual person. The basic elements that we are considering right now are what kind of users we have, the thermal comfort that is very important, also the gamification strategy, and the social products. As I told you, the social products mean try to communicate in a better way with the end user and also improve the communication between the devices, because all those devices are provide me with a lot of information in terms of energy. So I can have a better description using all the information from all the devices than instead of using only the thermostat information. So the main idea is try to create a social devices that all the time are communicating think, and sending information about how is the energy behavior of end users. This is the framework that we are trying to develop, and the main goal of this framework is that all the devices that we are trying to create are human-centered approach. I mean, the person is the most important for us, and saving energy is part of the goal. But if we know more about the needs of the end user and how can we improve the quality of life of the end users in terms of energy, I think that we are doing the task in a correct way. So in this case, we are using behavioral aspects, psychological aspects, and physical aspects. If you see in this approach, we are using some user type analysis and predictive modeling in order to send this information to the machine learning algorithm in order to tailor in the interface that already explained you. And another source of information is the metabolic rate that we are using in this case image processing. And also we are including the type of clothes that they are using. And this information also is sending to the image processing unit. And then we send this information to the machine learning algorithm. And we, in this sense, we are improving also more the tailored gamification interface. Those sources of information are running online, and the main idea is try to improve the gamification interface in order to saving more energy. If you see in this slide, you can see the adaptive model, and in this way we are trying to create this kind of adaptive models in order to improve the way that the comfort, the thermal comfort inside of the house, not only saving energy, but also the part thermal comfort is extremely important. And in this way, we have different scales for analyzing and studying the thermal comfort. And we include this information inside of the system. Because maybe you can say, okay, change the reference temperature in your thermostat, but you are losing thermal comfort. And the idea is not to lose thermal comfort. You have to have the thermal comfort and also saving energy. And this is the main idea that we are trying to deal with this kind of devices. So the methodology is more general in terms that you can learn about the end user, you can deploy the algorithm in the interface, and then you can propose a gamified interface, and then you can evaluate online all the time in order to improve the interface. As I told you, these kind of interfaces are running online. It means that they all the time they are learning and try to improve the way that they are communicating the energy information regarding the behavior of the end users. So for doing these kind of things, we have to model the energy inside of the house or a building. And in this case, we have to go to the first step, and one of the first steps is modeling the amount of energy that you are spending. Sometimes we also analyze some architecture aspects regarding the house or the building in order to try to create a complete description what is happening inside of this building or inside of this house, and how this device can improve the energy efficiency connected with another energy devices. There are different behavioral actions that we have to keep in mind, but we are focused mainly in human-machine interfaces and how is the response that we provide using smart thermostats. This is a very brief example. We have the information from the smart house. We can detect the behavior of the end user. We can provide a way to engage them using gamification and present a different interface that is a dynamic interface that is changing according with the needs of the end user. We are sending specific rewards in order to engage this end user and be connected with the community and try to save more energy in a community than using only the experience of one specific house. And all this is running in an artificial intelligence algorithm, and we are changing the interface. So at the end of the day, the end user is more aware to using the interface in terms of they are able to use in a very easy way the interface. We try to avoid the usability and functionality issues in this kind of interface. And for the end user, it's very friendly to use an interface that is designed for a specific person. I mean, if I have an interface that is a general interface, maybe I will avoid the use of this interface. So for me, maybe it could be very difficult. But if this interface is designed for my specific needs, I think that I will be very happy to use it, and I will can interchange information with the interface and save more energy at the end of the day. Those are some tests that we're running with different platforms in order to try to understand more about the end user and how it's behaving. And for the metabolic rate, we use video cameras, but those metabolic cameras are not used only for saving energy. They can be used also for detecting if some elderly person fell down and you have to send a specific message in order to say that there is a problem in the house or something like that. You can use at the same time this kind of video cameras. This is the reason that I was telling you at the beginning that there are some devices that can share information and be used not only for saving energy, you can use it for security or healthy problems. For metabolic rate, as I told you, we are using video cameras, and those video cameras can detect the position or the activity that you are doing. So in this sense, you can provide this information to the main system, and we can give you some advices regarding the thermal comfort, the type of clothing that you are using, and things like that. Let me move to the clothing isolation. For the clothing isolation also, we are using cameras. It could be the same camera, and you can detect the kind of clothing that they are wearing. So at the end of the day, they are wearing different kind of clothes, but you have to deal with this kind of situation in a real house in which they have different, um, they are wearing different clothes. But at the end of the day, you have to decide which is the best option for all the members of a family, for instance. So one of the key points here is try to deal with these kind of situations and try to say, okay, if I have a problem here, because they are wearing different type of clothes, what is the best decision? So you can run also an optimization process in order to try to find the best optimization uh, process in terms of finding the best thermal comfort for all the members of the house. And it's not so easy sometimes to decide what are the limits of this optimization process. But if you know more about what kind of activity, the type of clothes that they are wearing, so you can say, okay, this is the best reference point for the thermostat. And in this way, you can save energy and you can achieve a thermal comfort that is acceptable for all of the members of the house. Those are some studies that we are running in different experiments that we are using cameras, and we are detecting the activity, the type of clothes, and how can we deal with different members using different clothes, wearing different clothes, and also doing different activities. And all this is running at the same time in order to provide this information to the central unit. Let me remind you a little bit about that. So this is the central unit of the thermostat, and all this information is running and passing to the machine learning algorithm, and then is trying to send the information to the tailored gamified interface and setting the reference points in the inside of the thermostat. And let me move on. And I think that is all from my side. If you have some questions, I would like to hear them.
Wow, thank you so much for such an incredible talk, which is so fascinating. The topic is just obviously of interest. I'd like to begin by thanking you for making such a complex topic, which is heavy in physics and behavioral science, really accessible. I feel like I followed you through, so thank you very much for that. And it's such a timely topic, obviously, as world leaders are starting to travel to Scotland and meeting for the COP26, which starts this Sunday. And, you know, we're thinking about global climate targets and how to reduce our greenhouse gas emissions. And obviously energy is one of the big ones. So I love your approach and how you framed it, even at the beginning, that this is a multi-pronged strategy that requires, you know, clean energy like solar, but also this focus on energy efficiency, which is really fascinating because that's something that's feels very tangible in the way you presented it. So I guess I'd like to start by asking you, what is sort of the end user's interest, or what's the sort of uptake when you speak with people about this? I imagine it's at this research phase and you're doing trials, but do you see, when you talk with people, is there a broad interest, and how far do you feel this can spread? What's the potential?
As you know, there are different kinds of end users of a thermostat, but there are a specific group of people that are connected with technology. So they are accepted very fast to try to use these kind of approaches, but they are another kind of people that are reluctant to use it. I mean, the main goal here is try to involve the the all the groups that we have in a house or in a building. I mean, maybe you have people that is very friendly using technological devices and they accept it and adopt it. But they are a group of people that say, oh, I don't care about energy and I'm not interested in this kind of devices. So one of the key points here is try to use this tailored gamified interface in order to engage them and also to try to push them to save energy. So when we are running this kind of experiments, we are trying to involve of all kind of groups of end users. Sometimes it's so easy to involve people that already accepted the technology and they say, okay, I want to save energy, tell me how. But on the other hand, there are people that say, I don't care about that. In this sense, it's difficult to run some experiment with people who is not um, interested in this kind of proposals. But at the end of the day, if you show that the interface is trying to adapt to your needs, they start saying, okay, it could be interesting because it's not a general interface. They start watching that the display is changing according with the needs and things like that. And I think that this is one of the key points in this kind of experiments that we are trying to run. Try to to select different kind of groups and observe and register all the response that we have regarding the use of this kind of interfaces.
It's so fascinating, and I could learn so much from you, obviously. I work in climate change adaptation, and we encounter people who are resistant to that for various reasons. Sometimes political beliefs are challenging what they feel in terms of taking climate action. But your detailed research on which incentives work for which users is really fascinating. And to me, that is applicable in sort of some of the thinking that I do around how to get people on board for taking, sustainability action in their own life. It's really fascinating.
Yeah, and on the other hand, as I told you, when someone is talking about solar panels, solar energy, and they are spending the same amount of energy without saving any energy, I think that the problem is not completely solved because I don't understand how you can say, okay, I will install solar panels or green energy, and you are spending the same amount of energy. You have to install these kind of devices, but also saving energy. And if you want to save more energy, you have to change sometimes your energy behavior. Because if you only install a renewable energy source, is not solved, you are not solving the complete problem. And also you have to connect these ideas and behavior with the community. And the best way that we are trying to move to this approach is to use gamification. And we tailor it, the kind of rewards that we are sending to individuals, but also to the community in order to engage them.
I love that. I love that approach, and I find it so exciting. It seems like, sometimes it's easy to fall into climate despair and worry about the future, but these kinds of futures that you're describing as they scale up are incredibly exciting. So thinking about what you just said, and then in terms of scaling it, I guess two questions. Number one, the idea of a smart city and a smart grid, you said, I believe, is very much still conceptual. But are there cities in the world that are sort of leading in that space? And are there inspiration that we can look to? Sorry.
Yeah, yeah. In my opinion, China, US, and Europe, they have very good approaches to moving to the smart grid and smart city concept. Because maybe you can say, okay, I have a smart city structure, but the problem here is that the smart city is not only energy, it's transport, safety, and other issues. So one of the key points here is try to deal with these kind of things, not only with energy. So China has a very good electrical structure, and they have a very clear defined smart grid concept, and they are moving to the smart grid in terms of to include them in the smart city. And in US also they are very good approaches. But I think that if you are talking about a smart city, the problem is more complex because you have rural communities, and the rural community is also a part of the smart city, and only to think in the core part of the city that is living in downtown. And there are very different approaches and definitions about a smart city, but in my opinion, you have to include rural communities inside of the smart city, smart grids, or energy devices. So there are very few people that is talking about rural communities in smart cities or smart grids. They
Yeah.
they talk about the smart city in terms of downtown or the big cities.
That makes total sense. And sitting here in Canada, we have potentially a challenging geography for increasing energy efficiency because we tend to be quite spread out and quite rural over large areas. So it's interesting to think through some of those challenges. Um, I guess a final question for you is, in a best case scenario, what do you imagine the field would look like in 50 years from now?
I'm not sure. It's a tough question because it's changing everything. For instance, COVID-19 changed the way that we are using energy and the way that we are communicating. So right now, I'm not sure what will happen in this period of time because we can improve the way that we are living, but we have to be aware of what we are doing with the information that we have and how we can manage this information in order to improve the quality of life of the community of a country and the whole world. Because global warming is not a problem for a specific country, but you can contribute to don't continue doing the same at home. And maybe you can change your behavior. And if a community changing the behavior, if the country is changing the behavior, you really are changing things that are happening. But if you don't use the information in a correct way, I'm not sure what will happen.
Absolutely. That's such a great answer and very wise, obviously, in these future scenarios and in terms of all of the moving parts in these incredibly complex systems and challenges. Predicting where they go is is a challenge, and you avoided falling
Yeah,
into a trap of simplicity, so that I appreciate that.
yeah. Sometimes it's very difficult to talk about the energy because the people sometimes say, okay, energy is only for engineers, but there are a lot of areas that are involved in energy. In this work, for instance, is the human behavior the big factor for trying to promote a real change or a big change in saving energy? Because human factor at home or inside of a building is is a critical factor. Not only is to create a very well designed device that can detect how many people is inside of a room, and maybe it can program automatically when you are out or you are on vacation or things like that. You have to include the human behavior, how is the cultural aspects, how you can promote different rewards, and all these kind of things involve more than engineering studies.
Yeah, absolutely. Thank you very much for that. I have a question here from our audience, from Caitlin, who says, Dr. Pence, thank you for your presentation. I'm wondering about the affordability of such interfaces for the average consumer. Do you think smart homes are something that most households would be able to afford and implement in the near future?
this is the reason that the first slide was this one, because there are a lot of population that has a cell phone. So the central unit of processing is not a cell phone. It could be the cloud. I mean, you can process it on the cloud, all the information, and send the information to the cell phone. So you can, if you have a regular cell phone, you can have this kind of experience using this kind of interfaces. So we are thinking that these kind of devices that we are proposing can be controlled and communicate using the cell phone. And if we have a cell phone like a main point of interface between the end user and the system, we can promote that more people use these kind of interfaces. We are not thinking on one device in one house, very complex software and very complex hardware. No, we are thinking that these can be um, uh, implemented using a cell phone, and all the processing information, all the process of calculating things and things like that can be done on the cloud. So for us, it could be very accessible. And the key point here is try to use the information from the end user and try to improve also the quality of life. Because when I am talking about the quality of life, energy is a big factor. We cannot think a good quality of life if we have a blackout. So if we save energy and we can promote saving energy in a community, I think that we are doing the correct thing in order to improve the quality of life of this community.
Thank you so much for that response. And I think that's probably a beautiful place to end it for today. Thinking about the ubiquity of simple technologies, well, not simple, but availability of technologies like cell phones and the huge potential to contribute to both energy savings and sustainability initiatives, but also your focus on quality of life is really inspiring. And so I would like to, on behalf of our cohort and the audience, extend a huge thank you so much for such an inspiring presentation, and wish you well. We look forward to following your research going forward. Thank you so much.
Thank you. I would like to mention one last comment. When we have smart devices like a smart TV and a smartphone or a smart fridge, at the end of the day, we think in a smart device. But for instance, if I am using my cell phone and I ask to my cell phone, who is my best friend, maybe I don't have the correct answer from my device. Maybe he can think that my best friend is my boss because I talk a lot of times with him. And this is not a smart device. He knows a lot of things about me, how I'm feeling, the tone of voice, or maybe my posture can be a sign of depression. And these kind of things can be included in an integral system. So at the end of the day, we are thinking in smart devices in a different concept, not only to say, okay, I have a smart devices. No, the smart devices have to understand my needs and promote a good response in order to improve my quality of life. And these kind of things, they are not easy to deal. Also, the privacy in information is a very, very, very important topic. But I think that the correct approach is try to promote these kind of smart devices.
Thank you so much for that comment. I absolutely agree, and there's so much need and potential in this area. So it's a thrill to hear where you're pushing the frontiers in this space. So thank you again so much for your talk this morning.
No, you're welcome. It was my pleasure, and I will be available the presentation. And anything that you need, please feel free to contact me.
Thank you so much.